So welcome everyone to our second session of Introduction to Networks, which is our the first course in the CCNA ITC courses that you are working on. We are going to go over today Chapter 2, which is really neat because I like the fact that the new curriculum has started going directly into how to configure, and I don't know why in the world that popped up, how to configure a router and a switch. Now, I'm going to pull out the chat box, so if you have any questions, you can do that. I'll also pull out participants, that way if anybody raises a hand or anything, and I'm also going to pull out my recorder button, so I've got that. So what we're going to talk a little bit about is the network operating system, but we're going to talk about the network operating system that runs on Cisco devices and how we go into those devices and manage Cisco devices. The Cisco operating system is called the Internetwork Operating System, or the Big iOS instead of little iOS. So it doesn't run on Apple devices, it runs on Cisco devices. And the iOS runs on both routers and switches. Of course, it has some different functionality depending upon what device you're running it on. But it is honestly just another operating system that's been specially designed to perform the tasks that you find with networking gear. For instance, performing security tasks with things such as access control lists, or possibly firewalls, both stateful and stateless firewalls. Routing, be either static routing, dynamic routing. We'll talk a lot about those as we move into the next course, Routing and Switching Essentials. Quality of service, the interface, managing resources, all of those. But one of the things I want you to take away at the very beginning is a router is nothing more than a specialized computer. That's all it is. It's a computer that has special ASICs, or application-specific integrated circuits, that are designed to do networking functions. So they are built to do a task, a single task.
Yesterday, much less.
Sorry, I had to shut my door because my noisy neighbors, office neighbors. So, but it is a hardware device that has an operating system, and the operating system has a shell, which is the interface that allows the user to interact. In our particular instance, for most Cisco devices, you're going to be using a command line interface. There's a kernel that interfaces with the hardware and the software, so it's that interface between the hardware and the software functions. Now, I'm doing a lot of reading on some other items, CCNA CyberOps, and looking at CCNA or looking at operating systems, in particular NT. So you know all about the NT kernel and how the kernel, there's a kernel mode component and then there's user mode components on where they run. We also have, of course, the hardware, the physical parts that are there on a computer or on a router, which in our case is going to be things like RAM, ROM, NVRAM, and we'll talk about all these as we move forward. So the purpose of an OS is in most cases to provide an interface to the resources that the computer device is giving you. So in this case, for the iOS, it's going to be to allow that networking device to perform its networking task. We're going to do that through configuration at a command line interface, and we're going to access the devices in a couple ways. There's really two different, and you could say, well, it's two major ways of doing management to a Cisco device, and those are what we call in-band management. Okay, and in-band management is when you're performing any management over a network interface. Okay, so for instance, in this case, we talk about VQI lines. All right, and with those, you could telnet to it, which you'd never want to do because that's insecure, or you could SSH, which is secure shell, which is the preferred method of doing in-band management. Now, the other way of doing it is out-of-band management. Now, out-of-band management is when you connect locally to the Cisco router or switch using the console. Okay, so we've got the console. You also could, technically you could say that out-of-band management could be the auxiliary port. I guess you could in some way say the auxiliary port would be in-band too if it's doing a dial-up, depending on how you got it set up, whether you're doing a reverse telnet or maybe dialing into a network and getting access. But out-of-band is typically considered to be just the console port. Now, the console port on a router is a port on the back that is a blue port. It is typically found on the rear of the router and switch with a, I always say Carolina blue because it is the color of UNC Chapel Hill. I went to NC State, so we would rather have red console ports, but I'm going to pull up a picture here so you can see it. And here's an example, multiple examples of a Cisco console port, but here's one of a 2960S series. You'll notice that the console port, again, this is Carolina blue, and you'll notice that this is an example of a console port that has both an RJ45 connector and it has a mini USB. Now, this doesn't mean you've got two separate connections. This is either or. You're either connected to the mini USB or you're connected to the RJ45. So you can have someone connected to this and to this. This one actually also has a management interface, management base T. But for us, we're just going to talk about the console here. On older routers, you may see something like this, which is just a RJ45 only. All right, so this is a Cisco 2600, and that's actually found on some of the older switches too, so just a typical RJ45 connector. Cisco's console cables are always blue, and they connect to a terminal emulation program that will allow you to connect to the console. SSH is different. It allows you to connect across the network. There's a public-private key pair generated, and you can connect, and everything sent across it is encrypted, so you don't have to worry about your login credentials being stolen. Telnet is not secure. It's the same thing as SSH as far as going over the network, so it's in-band management, but you do not have security with Telnet, so we really should not be using Telnet. So, and the aux port, again, is considered out-of-band management because if you ever use an aux port for configuration, you will be able to put a modem on it, connect remotely. One thing I will tell you about aux ports, and one of the things that, and here's a picture of an aux port, I'll bring this over here. If you ever need to get in a router and for some reason you're locked out of the console port, plug into the aux port and connect to it just like it's a console port, and you may be able to get into the router depending on whether or not it's been misconfigured or not configured securely like it should have been. So terminal emulation programs, here we have PuTTY. This one's very easy. There's Tab PuTTY. There's all types of different ones. Teraterm, Secure CRT. Used to be HyperTerminal back in the day. But when we connect with our PuTTY, if we're doing a console connection, we do a serial because we need to connect from a serial port to the router, or we may have to do a USB to serial adapter, which is what we have to do in most cases now because most computers no longer have a serial port, especially if you are on a laptop, you're not going to have one. So, and I'm going to show you a USB to serial adapter. USB, well, there's actually so if you're actually running a laptop with no serial port on it, you can take and buy one of these USB to serial connectors, and then you can plug this in the USB, load the drivers for it, and then you can go in and connect this to the blue console cable, which is the console cable for Cisco, which has this on it. If you're using the newer mini USB connection, you may be able to actually do that, or if you're using Cisco's USB to RJ45, you may be able to actually load the drivers for that. The big thing I will tell you about this, when you use a USB to serial connector, the drivers can be a little flaky. So you just have to be careful that you buy one that is of a good quality. So there's Teraterm, Secure CRT, very similar. You just have to learn how each one works. So modes of operation. I'm actually just going to talk about these more than anything else. A router, when you go into a router or a switch, so I'm going to go into a lab here. Now, normally to do this lab, I would actually have a PC, and I would I'd connect the console port, console cable into a serial port, and then connect to the console on S1. Because of the way NetLabs works, we can just click directly on the switch, and it's actually opening a reverse telnet session to the console port, which really gives us out-of-band management. Even though we're going across the network, it's simulating out-of-band management here. So here's a switch, and I'm going to put in passwords. I hope I put it in right. I did not. Make sure I got the right passwords. Of course, it's not blank, so I'm going to have to actually do a password recovery. Oh, it helps when you actually click in the bad secrets. There it is. Okay, so I'm in the switch now. And one of the things I want to show you is you'll notice that there are two different modes here. You will see that it says user access verification. I've got to log in before I get to go into one mode. Now this, it should be Cisco, which it is. And you'll notice that it's the name of the device and then the greater than sign, or the alligator mouse sign. That's what I say, but it's the greater than sign. This is a mode called user exec mode, or user mode. Okay. In user exec mode, you can look at items, but you cannot change them on a device. So if I pull this back up, one of the things you'll notice too, and you're going to learn about how routers and switches work, but the question mark is your friend. And when I do the question mark, you'll see all the available commands at this user exec mode prompt. And in this case, you'll see there's one, basically maybe a page and about 7 or 8 more commands. If I go to show and question mark, you'll see that all the commands that are under show. There's also a beautiful thing here with let's say I know a command begins with S, but I don't know anything else. I can put S question mark, and it gives me all the commands that are at that prompt that begin with an S. You can also use things such as tab complete. So when I do SH and tab, it's going to tab out to show because there's no other command that starts with SH. If I put S tab, it won't do anything because that is ambiguous. It doesn't know what that is. Okay, and I think they've actually set an alias so the S int brief and S int GI. They actually set an alias here so that S is in fact show, or maybe it's not. Let's see here. Oh, watch this question mark. Yep, it is. So they set a little alias so the S is show, even though that's not a actually not a non-ambiguous command. But the big thing here is you'll see when I do an entire list of commands, it's a very short list at user exec because I can only really look at the device, not provide configuration here. If I go type enable and put in the password, which you have to set these passwords, and you'll learn how to do that. And if I type them correctly, you will see that I'm now at a different prompt. I'm at the privileged exec mode, or privileged mode prompt. If I do a question mark here, you're going to notice there's 1 page of commands, 2 pages of commands, 3 pages of commands, and then a couple. So there's a large number of commands that are not available in user exec mode. I can also go in here now and I can do config T, which is short for configure terminal, and I could change the host name to test switch. You'll notice it's automatically changed in the running config. So inside of privileged exec mode, I have access to all commands and I can make changes to the device. All right, so again, user exec mode, it's where it's delineated by the greater than sign. You can only look and make no changes. You're able to monitor but view only, so basically kind of like a read-only mode. And then once you go into privilege exec mode, you're able to perform all configuration commands and the task. This is, by the way, assuming that there's no type of user controls set up that are discussed later in like a CCNA security class, where you can set different move commands to different levels. So again, here's our other items that we can have with configuration modes. On our device, excuse me, on our device, you noticed when I exited, okay, so when I exit, I'm prompted for a password, okay, and I put in Cisco, which is the password, and then I'm going to go class, which is enable secret, but I can actually go into line con 0, and I could change the password. Now, right now, I'm going to do a do show. Now, by the way, typically, I couldn't do show, run, pipe, begin, line, console 0, because that command's not allowed. But if I do a do, do, I should, and I actually put a space in here. I should have hit Control A, but, and it didn't do it right because I didn't put it in correctly. But if I do a do, show, run, I'll just do it quickly. I can hit spacebar a couple times, and I will end up down here, and you will see a line con 0. That's why it didn't work, because I spelled it out instead of line con 0. You'll notice my password is Cisco. Now that's the password to get into the console line when you're connected to the console port. I could change that. Okay, so I'm in config line. Now this is a line configuration mode, and I could do password test. Control Z, and now if I type exit, I'm prompted for a password. I'm going to try Cisco. It doesn't work, but if I try test, it works because I changed that password. So that's one sub-configuration mode, line configuration mode. You will also see inside of devices such as this switch. I'm going to put class here. You're going to see show IP. I'm going to do show IP int brief, which is show IP interface brief. And you will see all of the interfaces on this device. So all the fast Ethernet interfaces, the VLAN 1 interface, all of those items. Okay. So I can actually go config T and I can go int VLAN 1, and now I'm in interface configuration mode. Now, don't freak out here. You're going to learn these. You're going to use these modes over and over and over. This is just showing you there are multiple different modes available on the Cisco iOS. These are videos that are loading, and for whatever reason they're not loading right now on my machine. But these videos are just short, showing you how to get between the iOS modes, which is exactly what I'm doing for you. A couple ways you can do it. You can actually type disable. If you do that, disable. I actually got to be out here, exit. And then you can type disable, and I should drop all the way out to privilege exec mode, and you'll see that. Or I could have put, I could simply just type exit, and it would have exited it all the way out also. You got to remember I changed it to test. All right. Now another thing you can do here that's kind of interesting, if you're all the way in, let's say int VLAN 1, and I wanted to drop completely out of this line or interface configuration mode all the way back to privilege mode, if I hit Control Z, it will drop me all the way back. You'll notice here's something I teach my students. You'll notice that the cursor ends at this little line that says, hey, it was configured by the console. But if I had been typing something in the middle of that, it would have ended up somewhere in the middle of this particular output. So for instance, let's try this again. Let's say config T, I'm going to say int VLAN 1, and I'm going to type Control Z, and I'm going to start doing show, right? And you notice that I can't tell what's been typed and what hasn't. Now it worked because it took it. I always teach students to put this in on their line con 0, and it is simply logging synchronous. Oops, I got to spell it right. Logging synchronous, and once that is on, you will notice that I can do a show, and as it'll automatically return and just give me what I was typing. So you don't have to try to figure out, well, what was I typing? Where's it at? but this logging synchronous commands, and they teach you that when you do the lab. So that's not a real big item to remember at this point. I want to stop for just a second and ask you if there are any questions about the two primary modes on an iOS device, user exec mode and privilege exec mode, or sub interface or sub configuration modes. Okay, Keisha? Or anybody? Keisha, I think your mic was working, it looked like.
I have no questions.
No questions, James? Okay, all right. Well, let's look at the basic structure of an iOS command then. Typically, you have the prompt, so it's going to be at a user exec or privilege exec mode. You have the command, a space, and then keywords or an argument. So in this case, this is show IP protocol, so that's the keywords for this command. And this one, it's switch, ping, and then the argument for that. In other words, this is ping the IP address 192.168.10.5. Inside, when we start looking at Cisco examples, most of the time what they're going to do throughout everything that Cisco does is you will see the command in bold, and then you will see any argument as an italic. Okay, so that's basically in italics, and it says this is a variable that can be replaced with the argument of your choice. I told you or showed you a great deal about these help features. I don't know why this is not loading for me right now. I'm going to have to check that. But the different context sensitive help, where you can always just use the question mark. Okay, and I said it's again video. So here's a bunch of the hotkeys. This saves you so much time, folks, if you learn these hotkeys. So the ability to say, you know, show IP interface brief, and then for some reason I want to jump to the very beginning. If I hit Control A, it takes me to the first character of my command. If I hit Control E, it takes me to the end. All right. You can hit Enter, and it will run the command. Obviously, I don't use these Control D, Control K a great deal. I'm sure you know it works fine, but I just don't use those a great deal. I do use tab all the time. So like show IP int interface brief, and the tab, just like inside of Linux, it works just like Linux in terms of tab completion. So Control Shift 6X is good if you happen to have a problem and you need to get out of a stuck command for some reason. And then Control Z can be used to drop completely out of configuration modes when you're inside of them. So just be aware, it's nice to have it to where you can have these help features and these fast hotkeys. So again, we do con question mark, and you see the configure and connect. And see, I can't tab complete because that is ambiguous. Now, if I put CONF, it will tab complete, or if I put CON in, it will do connect. But that's only because they are not ambiguous once you get past that point. So they'll actually tab complete. All right. Let's see. There's a packet tracer that's going to have you going through the iOS. Again, make sure you download it. Be aware too, again, that there are many of these packet tracers, and especially in the first couple of chapters of this course, that are what I call look and see packet tracers. All right. So you've got this packet tracer here, and I actually think this one has you connecting some items. It does. You've actually got to connect. You've got to connect this to get your score. So this one you can do an actual check results and do a screen capture on it. Because you got to go in here and go console cable PC1 RS232 up to a console. And I got 5 points, 20 points. All right, so technically I'm done, but now you got to go through all the different commands that it's going to ask you to do here. So you can actually go to the terminal program on the desktop. It's at 9680N1. Flow control is typically on X on, X off on most machines. Make sure you set that to none, especially if you're using the USB to serial adapter, because those can cause problems if flow control is on. But then we can go in here and actually start doing our different parts of the lab as far as connecting, just like we're at the console of a real device. Check results will give me my score now, and you'll see I've connected it to console, and I've connected everything the way I should want it. So if you have this, take a screenshot and upload it with your completed PKA file. If you don't just take a picture or a snapshot that says, congratulations, you completed the activity without the assessment item, because I know you won't be able to click on it. Does that make sense? There's a little bit of confusion on that. I want you to be aware that that's what I want. Okay. So we also have a lab here established on a session with TerraTerm. The problem you're going to have is when we go into NetLabs to do our lab, so I'm actually going to look at scheduling for individual learners. I'm actually going to go in here. When I schedule you for building a simple network, you can see that that's not even an available lab in here. So I don't ask you to do that in this particular NetLab setup. It would be extremely good for you to do this in your lab at your school with your own gear. And you may not use TerraTerm. This has TerraTerm in it, but you may very well use PuTTY. If you do, you'll just have to change the directions to use PuTTY to connect. You really need to do this lab because that's how your students are going to access the real gear sitting in the classroom. So when we go to configure a Cisco device, what is one of the first things we need to do? We need to name it. The command to do that is hostname. All right. It is a name, starts with a letter, cannot have spaces. It ends with a letter or digit, and it can only use letters, digits, and dashes, and be less than 64K in length. You should use your company standard for hostname of your devices. And here we have an example of switch floor 3, switch floor 2, switch floor 1. You may even want to be more detailed, but that would be dependent upon your company's environment and their standards. Very simple command to do this. You go in, first you must be in privileged exec mode. Then you go into, this is called global configuration mode when you just have config. That changes anything that is globally important on the router or switch. So for instance, the host name is globally important. So that is a global command. So you can put in host name, switch floor 1. Now, on a Cisco router, there are two different configurations. There's the running config, okay, and that's the configuration that is running in memory while the device is up and going. And there is the startup config. Okay, the running config is it's stored in RAM. Okay, so if you have something in the running config and the machine is turned off, it is deleted. It is gone. The startup config is stored in NVRAM. That means it will survive. This is non-volatile RAM. It will survive a reboot. All changes you make by default are not placed into the startup config. They're placed first into the running config. You then have to issue the copy running. This is the very longhand way to do it. Running config to startup-config. Or you can do cop rs or write, which is, this is an old command that stands for write mem. All right. So let me show you an example of this. So right now, I'm going to go in here and do a show running config, and you see the running config with the host name of test switch. I will do a show startup config, and you'll see the host name is S1. So even though I've changed this with the host name command, because I have not saved it into the startup config yet, if this machine were to reboot, this switch were to reboot, it would go back to the host name of S1. Now that's pretty minor, but imagine you spent a couple hours configuring a router and you forget to do a copy run start and the power flicks or the router is rebooted for some reason and you lose a couple hours worth of work. I've also seen examples where people have put in configuration changes that fixed an issue or where a new configuration that was added in say adding new IP address interface or something of that nature, and forget to save it. Months down the road, the power knocks off, and then suddenly a part of the network is no longer reachable, and it just because they forgot to save it. So I can do a copy running config to startup config. If I do this and do a show startup, show start, you will see now that the host name is test switch because I saved my running config into the startup config. I can also do, again, coprs, which does the same thing, or write mem.wr, which is the shortest version. Now, on the test, if you take any Cisco test, use copy running config startup config. But real world, I always use write because it's write mem. It's just much simpler and much easier. Okay, and then here's what these are called syntax checkers, and you can actually go in here and you can click in here, and they want you to be able to configure terminal, and you have to put the entire command in. If you try to shorten it now, so I got host SW, this would work on a real switch, but it will not take it in this syntax checker because you must enter the full command. So I have to put in host name SW dash, and this is good for your students and for you to learn how to use the long form of the commands until you're comfortable with the commands. Other devices, other items we've got to be able to do is secure privilege exec mode. We don't want people to be able to just simply plug into our console port and have access to the privilege exec prompt, because then they can make changes to the device. So what we're going to do is we're going to set a couple passwords, and those passwords that we're going to focus on, we're going to focus on the enable secret password. Now there's an enable password, but even if, I know that there are a couple labs that actually have you set the enable password, you should really never use that because it's stored in the running config as clear text or in a very easily unencryptable form, even if you do a command code service password encryption. But the enable secret will control access to privileged exec mode. Okay, so if I go over here and I go config T and I go enable secret, and I'm just going to go test. Now that's a terrible enable secret. You should never use that. Always use uppercase, lowercase, alphanumeric. But now if I can do Control Z and exit out, and I want to do enable to take me from user exec to privilege exec, the password is now test to get in. So I set the enable secret. We also talked a little bit earlier about console line. Oops, hold on. You gotta remember to do the right thing here. And you will see that when I do a show run pipe begin line con 0, it shows only the running configuration starting at that particular portion of the running config or the configuration. But line con 0, you'll see I can set a password to control access to the console. I can also set a password to control access to the VQI lines, which is the in-band management, which would be via SSH or Telnet. In this case would be Telnet because we do not have SSH set up. So those are other types of passwords that we need to set up. So here we see an example of privilege exec password. I just showed you that. User exec password, that is the console password. Make absolutely sure your students know that Cisco and class are horrible passwords to ever use in the real world because every student has used these forever and a day. Okay. On a Cisco switch, by the way, there are 15 VQI lines, actually 16, 0 to 15. On a Cisco router, there's 0 to 4 or 5. That's what we typically do. You also will see, this is something that's very interesting because you will see if you look at the running config, you can see the password on the V2I in the console in clear text. So they are very susceptible to what is called shoulder surfing, or someone being behind you and seeing it. So there is a command called service password encryption, and that command will then, you'll notice I'm using the up and down arrow just to run the same command again. You'll see now those passwords are encrypted because I use the service password encryption. This is very easy to decrypt. In fact, if you search anywhere for Cisco level 7 password decryptors, you'll find them, and you can just dump these in and get the answer immediately. But the good news is it keeps someone from just casually shoulder surfing and seeing that particular password. So that's what this service password encryption command is about. We have banner messages of the day where you can actually go in and set a banner message. Those banner MOTD would need to be set to something that is set by your legal team. It needs to say all access is, no unauthorized access is allowed, whatever your legal team would put into their security policy. Okay. And then here we have again saving the running config into the startup config so that it will survive a reboot. And it is very important that you remember that the running config is in RAM and the startup config is in the RAM, so it does not get lost when you reboot. So I've already showed you this, doing the running config, altering it. This is where you can capture a text file of the session where you're putting things in. Typically what I actually do is this. If I want a copy of the running or startup config in text, I just go in here and do it like this. Go all the way down to the very end, and then I just grab it like this. So I just go in here and go, actually, you could do it right there. And I just grab this and pull all the way down and save it to a text file. And just edit, copy, and then you can edit, paste it. But this lets you, the only thing you've got to do when you do this is go in and take out these mores. Okay. But you can also take, depending on your terminal program, you can just do a command and have it dumped into a text file. We have on our devices, we need to put IP addresses, and these are basically, I'm just going to tell you right now, they're kind of like telephone numbers. You got to know what IP addresses are, but we will be applying IP addresses on the interfaces. Very simple command. We look at the interface itself, and then we use a command called IP address, the address, and then the mask. So this is just talking about DHCP and static assignment of IP addresses on a Windows PC. This is something interesting because a switch does not have a physical interface. When you look as far as a physical interface that you can put an IP address on, a switch is designed to have ports that you put devices on. So when I do a show IP amp brief, you'll notice that these ports are not, these are switching ports. They're not designed to be routable ports. So if I want an IP address on the switch, I have to create what's called a switch virtual interface. Now, there are some switches, depending on their variety, that you can turn a port into a switch port, but for the switches we're going to deal with in CCNA, we will go into these to interface VLAN, some number, and then we can apply IP addresses to that particular interface. I'm going to put 12.2, and then a subnet mask. And then once you do that, oops, might help if I put .0. Okay. Now if I do actually I'm just going to drop out and just hit, be lazy. All right. You see now I've changed that switch virtual interface IP address to 192.168.12.2. So we can assign interface IP addresses on that switch. And then we can verify it with that show IP interface brief. This is one of my favorite commands because it allows you to see all IP addresses on a device. Very nice. And then you can also ping to get connectivity test across. Now, folks, there's a large number of things in this particular chapter, but the beauty of it is this chapter gets you directly into hands-on configuration of Cisco devices. So you're going to be able to jump in with this particular chapter and start doing labs, which is really neat. You won't have to wait around 10 or 12 chapters to finally start configuring devices. So we are going to have you work on those labs this week. They will be due on the 8th. So continue to work on those. And if you have any questions, please let me know. And I'm going to stop the recording real quick.